Alright, hi guys. So today we're going to be talking about radicals. Radicals is a very important unit as this will help you with, finding the roots of the function and finding solutions for quadratic functions and sine and cosine functions. You will see a lot of radicals in
Motion detected at the front door.
you will see a lot of radicals in trig too. So let's go ahead and get started. So when we hear the word radical, the first thing you would think of is that shape. And a lot of people think that that is a square, but actually it's not only a square root, it can be any kind of root, and I'm going to show you why. So here I have the letter n. N could be any number, any positive number, and or it could be negative, of course. And here I'm going to have b, which is the base. So I'm going to start by saying that n is the index and b is your base. The base can be a number, it can be an exponent, it can be actually any term. All right. And this sign, I'm just going to write it down so that you know if this is the first time you see this kind of form, you know exactly what this is. So now what does it mean when I have a radical? Is all this radical one term? Yes, it is one term. And what does the n mean? N is the index, which in other words is your exponent, but in a fraction form. So let's just talk about examples, and we're going to probably learn it more through examples when you see it. So I have a square root of 9, and this is square root. That means index is 2, alright? And we also see it sometimes in that form, just 9 without writing the square root here. I mean the second power here. It's the same thing. Now, the base is 9. The index tells me how many times, how many groups should I have? Or how many groups should I have? So in other words, if I think of the number 9, 9 is 3 times 3. So I can have one group of 3 times 3 because I'm going to circle them in groups of 2. Alright, so if I have the index 2, that means I should group them in groups of 2. If I have index 3, that means I should group them in groups of 3. So let's say I have that square root of 9, which in other words is square root of 3 squared. Now when there is nothing over here, I automatically know that this is a 2. So I'm going to cross out all this with that, and I will have 3 taken to the outside of that square root. Another way to explain this, that's probably going to be more complicated, but it will help you more when we get to different indexes. And you should know your exponents very well. So if you don't know your exponents, you need to go back to the lessons. We have about exponents. So let's go ahead and do square root of 9 to the second power. So that's the second method. Square root of 9, which is 3. Okay, let's do this, which is 9 to the power of, see this is 1 here, to the power of 1 over 2. So in other words, I can get rid of that radical and substitute it with whatever exponent I have here, and this, the index, is your fraction. So let's see how many groups of 2. So how many groups of 2 can I get out of the 9? How many groups of 2 can I get out of the 9? And why I want groups of 2? It's because my index is 2. So if I look at it, I can do 3 squared all to the power of 1 over 2. Now I have 2 exponents here. How do we multiply exponents? When I have an exponent to exponent, what do? I just multiply them. So it will be 3 and 2 times half, which is 3 to the power 2 over 2, which is 3. 2 over 2 is 1. So your answer is going to be 3. Alright, I know this is more work than the other one, but I always like to see, let's put here first method. But I really like to, that's, the beauty of math, that you can actually do the same question in different ways. I'm going to give you one of the you try part, and then questions are going to be, examples are going to be harder. So let's do example 2, which is the you try. Alright, let's do square root of 36. We're going to do it in both methods. I would suggest you pause the video for a minute and you try it on your own. I'm just going to go ahead and do it right here. Method 1. So I know that my index is 2 because there is nothing here. When there is nothing here, then the index is 2. That means how many? So let's do this. Let's do 36 is 6 times 6. So I can have one group of 2's for the 36, and actually that's what I need because I want it to the second power. So it will be square root of 6 squared, and again this is 2 over here, so that 2 is gonna be crossed out with that 2, so our answer is gonna be 6. Method 2, again the same concept, the index is 2, but instead I have square root of 36 is 36 to the power of 1 over 2. I got 6 squared to the power of half, which is 6. I'm going to multiply these because exponent to exponent we multiply them. 2 over 2, which is 6. So square root of 36 is 6. Alright? We're just kind of proving it because when I go slow and get to the harder ones, at least you have a better understanding of how are we getting to these numbers. Alright, let's get something just a little harder here. Let's do example 3. What if I have square root of 128? So again, when I don't have anything on the index here, I know that the index is 2. So I'm looking for groups of 2's. Alright, so how do I do this? Now I know 36 was easy because I know it's 6 times 6. For this one, I want you to do the tree, whatever you guys are used to do, whether it's the tree or the factor, whatever works for you. I like this method, where I do what is the smallest number I can divide 128 with? It's 2. No, other than 1. So it's 64, again 2, it's 32, again it's 2, 16,
16 is 8.
2, 8, 2, 4, 2, 2, and 2, 1. Now, for this number, I'm going to look and I'm going to say, I need them in groups of 2 because
Motion
my
detected at the
index
front
is
door.
2. So I'm going to go with group 2 and 2. So the square root of 128, remember, if you multiply all these, you should get 128. That's how you're going to check your answer. So that would be square root of 2 squared, because each one of the ones I circled is the same as 2 squared, times 2 squared times 2 squared times 2. Alright, now which are the ones that I can take outside the radical? We know that this is an index of 2. That means anything that has a second power is going to go outside the radical. So this is going to go outside the radical as 2 times, this is going to go outside as 2, and this is going to go outside as 2, and then what do I have left? What do I do with that square root of 2? Nothing. I'm just going to leave it inside the radical. Now, what is 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. So that's 8 square root of 2. So square root of 128 is equivalent to 8 square root of 2. And this is the simplified radical. This is how we simplify radicals. If you have any questions, just, leave it in the comment or, or you can email me or text me. So now I'm going to do the same one, but we're going to twist it a little bit. Alright, we're going to do example 4. Example 4 is the same number, 128. I just want to show you the difference of how we do things when they're even though the same number. But I have an index of 3. So now I know that my index is 3. That means I have to group each 3 terms, or same terms I should say, together. Alright, let's see how we're going to do that. So we call this cubic root of 28. So that is called cubic root of 128. So we're going to follow the very same steps. We're going to do the 128. I know I did that earlier, but I'd like to do it again. 128, that goes 6. Actually, I'm going to do it the tree method. I know some kids, they like to use the tree method. So which is 2 times 64. This cannot be simplified. I'm going to circle it. We simplify this more. It's 32 times 2. This cannot be simplified. I'm going to move on and simplify the other one, which will be 16 and 2. And then, I'm sorry, I should have circled the 2. And then for this one, we got 8 and 2. 2 cannot be simplified. I'm going to circle it. For this one, I got 4 and 2. 2 cannot be simplified. And then we got 2 and 2. This method and the one I just did here, they are the same. It's just, some students learn it this way, others learn it that way, the tree method. Both of them will give you the same answer. So let's go ahead and put this in that form. So 128 is equivalent to 1, 2, 3, 4, 5, 6, 7 twos. 1, 2, 3, 4, 5, 6, and 7. Now I need to group each 3 of them into one group. So that is 2 cubed times 2 cubed times 2, which is equivalent to 128. So if I put it back in my radical, or in my cubic root, this will be cubic root of 2 cubed times 2 cubed times 2. Now, just the very same concept as the square root, since I have a cube in here, that will cross out this radical with that one, and that 2 will go outside the radical as 2. I have that cube with the radical, they're going to cross out that cube, and that 2 now is going to go outside the radical as 2, and these are multiplied. Now what's going to happen to that cubic root of 2? It's just going to stay in there because I cannot take it outside the radical. You have to write the 3, you have to keep the index in here. So 2 times 2 is 4, cubic root of 2. Now there will be a lot of examples on the very same concept with harder examples, because every new example have a new concept. So I'm just gonna stop that video for now. Or it's not really a new concept, it's just a new twist to it. Or things that you've learned before, you just need to be able to make that connection on the things you learned before and how to apply it to the new material that you're learning. So I'm just going to stop that video for now. And then I'm going to follow up with another video after that. Alright, I hope you guys have a great day and I hope you enjoyed the video.